So my name is Jochen Kumm. It's a real pleasure to be here in a very different environment. And I am the founder and CEO of Prevent, a medical AI company. And this, let's not forget about the second half, Stepan, like many good AI projects, is a true collaboration from Productize, really good company. They've really helped us, and speed is always of the essence. So it also made it faster. We have a good agenda. I'm going to talk about Prevent briefly. Our mission really is to protect vision in babies. Newborn vision, which ironically or sadly is not the focus of a lot of ongoing preventive or screening efforts. Artificial intelligence in healthcare, I'll touch on it, it's a huge topic. Personally find it exciting, and maybe you should too, because it's going to affect you and your family and your friends in very many ways. Too big a topic to cover, but I will cover some of it. I will talk about AI for the retina. Retinal AI and image analysis has been a very successful area of application. I touched on universal screening for vision loss, prevention, why we would do it and what the impact might be, and then Stepan will step in doing the hard and heavy lifting here about how this can be done, how it has, what one can learn from AWS applications of this, and we'll have a conclusion of some sort of it. So I was asked to introduce myself. Well, I am a mixed bag of goods. I used to work for pharma. I've spent a decade at Stanford running the Genome Technology Center, and I've worked in Africa with IBM Research. What I have always done is use data to try and make the world a better place. And my personal conviction is also that AI could and should be used for making lives better. I don't want to forget my co-founder in Prevent, Darius Moshfeghi, the director of retina at the Bias Institute at Stanford, and a true visionary who has helped a lot in terms of understanding what the clinical mission is. So before I get into this, I want to point out the true motivation of this. This is a conversation between Darius and I, where we looked at what happens in babies, especially with perspective on what it means to screen the eyes. So we have very good care for premature babies, both in terms of what's happening in the hospital and even good policies. So if your baby is born premature, everything's taken care of, it will be screened. There are established protocols, guidelines, there are even AIs being built for doing that. Then, mysteriously, from my naive point of view, there's a period of 5 years where there are no rules, no standard practices, and no real established procedures. And then kindergarten comes along, when it becomes obvious whether a child might have a problem with vision. And there is screening there. So there's this 5-year window where 4 million babies in the United States are born every year. They're neither screened and often not treated. That's bad, I think, in a place like the United States. What's more important in terms of motivating our work is that the best time for treatment is in the first 6 months of the newborn's life. In the first 6 months, 97% of treatment is actually effective. There are many different things you can do depending on what's wrong with the baby, from corrective lenses to patches to surgeries to drugs. But in those 6 months, you can do a lot. When the kid shows up in kindergarten, it may be too late. So the motivation was, why are we not doing this? And I will get to that in a moment. And I will try to convince you that artificial intelligence and sort of scale approaches are very, very useful in this case. But I'll leave that for a little later. So artificial intelligence in health, in my world, is being talked about a lot. It's been reasonably successful, and there are different visions of what it might take. There's the corporate vision, and IBM Watson Health has been pushing that a lot, where they see it as an enterprise level undertaking where you do big data solutions in the established way. There are technologists who feel that it's a wonderful opportunity for all kinds of new technologies, including robotics and machine learning and innovative surgeries and screening, scanning health records. And that's an interesting one. And then there's the clinician's point of view. I would actually recommend Eric Toppel's new book, Deep Medicine, which takes a new perspective, really from a practicing physician point of view, where he says AI can change the way we do medicine. And I think, well, he thinks there's a way for doing that better, more personalized, more attention to detail, fewer mistakes. They're all very good. I would just say that at the end of the day, what's driven us as a company, as a startup, and what I think has actually helped us succeed up to a point, is that we focus on what's actually needed for the patient. So we, of course, deal with newborns. I'll get into the details of this, but we want accuracy. What that really means, you want to get it right. If you say that there's something wrong with the baby, you want to get it right, and you want to find pathology. You don't want to miss things, really, what I should say here. The other thing that you need is intelligence, better clinical results. So you need to trigger something that improves the healthcare or improves the ultimate vision, prevents vision loss. Do something right. We are doing a little piece of that in a very practical way, and AI will probably add to that over time. But we're not. I don't think we're ready to sort of replace the doctor, just as an aside. What I like about the possibility of doing this in AWS and as an AI and also at scale is that we can offer this service to everyone, everywhere, and fairly equally. So ophthalmology is an interesting field. There are many ophthalmologists, but never enough. And so a little number here is that in the United States, there are fewer than 40 trained specialists that could do what our AI is doing for the entire country. So 4 million babies born, it's an unbelievably unfavorable ratio of experts. And so no matter how much money you have, you cannot get the service because you might not live within a driving distance of one of those 40 people in the United States. And so I think, as a general thing, health AI has provides an opportunity to make services a little more accessible, more democratic. And it's totally beyond the scope of this talk, but I think there's lots of convincing indication that AI solutions or machine learning solutions, deep learning classifiers have been and can be successful in health AI. And the fields where this has happened most often are ophthalmology, cardiology, dermatology, and oncology. By no means the only ones, but those are the 4 big ones, I would say. And there are solutions out there that you might try. I mean, dermatology, for instance, is you can take an image. There are apps out there, take an image of your skin and have a rapid diagnosis or analysis done as to whether it's melanoma or just skin discoloration. I think I like the Nature paper, Lesions Learned, the cover from out of Stanford, a little bit biased, but in the sense that they make some good points. It's very powerful, possibly very good. I do want to show you one thing here, which is relevant to especially this community. When they did a meta-analysis of how good is this really, the accuracy of artificial intelligence apps in these spaces ranges from 7% to 98%. So you can be absolutely terrible and really, really good. And so all that to set up Stepan is to say, you've got to do this right. I mean, it is not a turnkey solution that doesn't require excellent engineering and deep learning skills and optimization of parameters and validation. You also have to have really knowledgeable, strong people on the clinical side helping you train your AI, etc. So to me, this is both a hopeful and a disturbing number. Okay, and I will, in the interest of time, go relatively fast. But I think one of the things in health AI is that it might change the way we do healthcare. And I think that's both something that as a society and as technologists we need to think about and encourage. So right now, I mean, this is my own take on it, but I mean, many of us know this from personal experience in the United States. You have a personal physician, and they might refer you to a specialist who might then get a report from a image analysis specialist, and then it trickles back up, and you eventually get the information. I think that's the common experience for most of us. And so one of the things that AI might do, and a bunch of other technologies, is that we might find a very different model of patient-centered care. I would advocate that that's a challenge for the field. We're not there yet, but basically the specialist, the AI, the image technology, the medical records, and the physicians can all work together and basically provide the patients with an integrated service. So there's a beautiful quote. Oh, I hope. So there's an article, Review Artificial Intelligence in Cardiology, and from that paper, there is a hopeful statement. AI will drive improved patient care because physicians will be able to interpret more data in greater depths than ever before. And I don't even want to talk about who owns the data and whether there are technology solutions around that and whether, etc. But I'm deeply interested in that. So I think in the long term, this is something everybody should think about. So very quickly now, what drives us to do this, and what did drive Prevent, and why do we need the close relationship with Productize to get this done? So trained doctors are rare. In this particular field of ophthalmology, the United States is as bad as a developing country. There are many places in the world where you have one doctor for 100,000 patients, and that's roughly where we're at in some specialties in this country. So we have trained doctors are rare, large and growing numbers of patients, more, at least in this case, maybe not growing, but large number of patients, 4 million a year that we would like to look at. We do need to make sure that deep learning performs reliably and that the data are available. We do have to have the knowledge base in the training set, the testing set, and through the experts that is high quality. And I think ultimately to motivate this, at least for a startup, is that you have to have something to do, to respond to, treat the baby, treat the patient provide a clinically actionable result. And if I were to be controversial a little bit, I would say that in this field, all the papers we saw, the 4 big applications, cardiology, often people have focused on the neat, geeky technology problems of providing slightly better algorithms without thinking of where does this go? How? And I think success in this field, personally I would argue, is if you don't answer the last question, can I do something with it? Then you should be you shouldn't start a company, at least. Let's put it that way. So here, what is the retina? I'll try to go fast. The retina is the back of the eye. You can take an image of it. There's a little revolution going on in terms of the cameras. They used to be the size of fridges. Now they're basically iPad size that you can carry around. You can take the images. In the case of babies, you want to dilute the pupils. With adults, you can actually do it in a room. The retina is, if you look at it long enough, a very beautiful thing. I don't know whether you'll agree with me, but it's interesting anyway. The retina is a very interesting organ at the back of the eye. It has blood vessels, it has neurons, it has muscle tissue, connective tissue, and pigment. It's truly an organ, and it's actually representative of much of what goes on in the body. So it's still tiny, 2 millimeters thick, but it has 200 million or more neurons and a complex network of blood vessels. And it is, of course, a core component of vision. And that's what motivates us. We think about vision. Aside, I mean, the blood vessels alone are interesting because most of the drugs that we have today affect the blood vessels. And I was just talking to some friends from Stanford who basically now can take an image like this and tell you the age of the baby 2-3 days. So anyway, there's a lot of stuff we can do with it. Now, the previous one was kind of pretty. If you look at there are many things that can go wrong with the retina. And if you look at these, I mean, without going into details, you can see that there's stuff going on. These are the obvious ones. A human can look at this. However, unfortunately, many of the things that are pathology are not as obvious and are much smaller. But most pathologies are visible in the fundus image, and neural networks can learn how to find these things if trained properly. In our case, we did a back of the envelope calculation, and we basically believe that our algorithm captures about 12 years of expert training and looking at 120,000 images. And we demonstrate, but we know that that's true, and we demonstrated that the performance is there. We do, however, believe that artificial intelligence should partner with the ophthalmologist, because at the end of the day, I think I'm sort of on the conservative side. I don't like to say I'm going to replace it, but I can really help the ophthalmologist. So go a little bit faster. This is also not as important. It's history. People have been looking at images in ophthalmology for a long time. Primarily, they have done physician-assisted artificial intelligence and feature-based artificial intelligence. If you look at the bottom right here, you will see that they are trying to identify particular parts of the retina, and that's wonderful, but it's not as efficient, and it wouldn't scale to 4 million babies. So our approach is much more like that of a company called IDEX. It focuses on adults, it focuses on diabetes detection in the retina, but it also takes the approach that you can actually have an AI look at without having a physician assist. It's different in some ways, not important. So very more quickly now, what do the patients need? We need to build a solution that's accurate and a little bit more scientifically now. We look at sensitivity and specificity. The rest remains the same. We want to serve the patient. What does it really mean? I'm going to just show you here what our workflow is, with the point that I think that it's really, really important that you actually think about the whole workflow if you want to build a solution, as I said earlier. So we have a newborn. There's a camera already in the hospital and a trained nurse. So we have all the resources. We can go take the image. For many reasons, it's really advantageous to do this in the newborn ward right after birth within 72 hours. The parents don't have to come back. They don't have to comply. Everything's taken care of. It's a good environment. We get an image. We label it. And in fact, we could take about 10 to 20 images per baby, and we label it. So we find out, is there some pathology? Does it look normal? And I'm not going to go into the details because Stepan will, and it's anyway something of a black box. Then we ask, what does this mean for the patient? And there is an opportunity here. We are filing some IP on that, because that is a second level of AI that becomes clinically relevant. What do you make if you have some pathologies reported in different images and so on? Then you go to the physician, provide them with the information. The physician may recommend a specialist, and that specialist can then start treatment to protect vision. So and all of that can happen within the first 2 weeks of life without any extra effort. I mean, obviously going to the doctor, to the specialist will be an extra effort. But I think there are two beneficial outcomes here. Either you know that your baby is healthy, the eyes are healthy, you don't have much to worry. Second beneficial outcome, not as good, is you know that it needs help and the help's available. So again, scalability becomes an issue, but we have demonstrated that we can do that. Presently, we estimate that in the US alone, there will be 50 million images a year. If we do this, what do they really look like? This is a sample, right eye, left eye. And I already explained to you the process. We have an image, operate camera, upload the image. We interpret the images in the cloud, wonderfully efficient. So we have 2 levels of AI here, classification and pathology assessment, and then we refer and treat. and I'm going to go relatively quickly. I mean, we did this right. I think I could prove this to you, but not in a talk like this. We have built a database of almost 350,000 fundus images from babies, suitably diverse, lots of ethnic mix, representative of, say, the US population. That represents, at this point, 35,000 babies in our database. We have also basically signed the top 10 pediatric ophthalmologists who can actually do that, to capture our 12 years of expertise, and 25% of those data are being expert labeled. I already covered that. I'm not going to mention the fact that we have, of course, solutions in place thanks to collaborations that make sure that this is private and HIPAA compliant. If you are a scientist, there are things you can do with these images that are leading to new insights, such as identifying different types of pathology related to segmentation in blood vessels, general pigmentary distributions, and discrete pigmentary clusters. This is a relatively new finding. And I should point out that no one knows today, in the absence of having a database and a way to look at large numbers of information, we don't actually, I think we know more about the pediatric retina at this point than most people, because for obvious reasons. Now, if you're an investor, since we are a startup or a small company, is this worthwhile doing, right? And so we have been reasonably conservative. The cost of screening and then treating the babies, $4 million a year, would be about $1 billion a year. It's a very rough estimate, but that assumes that all, including surgeries, etc. The benefit for society, or the cost savings, are about $3 billion a year. So it's worthwhile doing. It's hard, and benefits accumulate over a lifetime. So, and you know, ask me afterwards how we calculate that, but it's very legit. Health economics, and I will go very quickly So our model is super simple. We have a baby, we take some images, we run an AI, and we either determine that it's normal or it has some pathology and needs specialist attention. This is very different from ongoing test. This is not ophthalmology testing, but baby tests. There's a history of what was usually people check for one single disease and ask, is it there? From personal experience, advising many friends, this is incredibly stressful for the parents because they do not fully understand what's being tested for. What's more important to me is that if you do that and just look for specific diseases, instead of looking for the overall picture, you're going to miss things. This is a rule of thumb that I would have to give another talk on, but 30 to 40% of existing disease can be missed if you just look for specifics. Probably the most convincing one is that the University of Michigan did a study earlier this year, published a study earlier this year, where they did all the tests, came back healthy, and then they did, in this case, a full screen and genome scan, and 40% of babies had something that was totally missed. So all that to come back to saying screening is better in some situations than diagnosis. This is details, but essentially, we are not doing enough in after birth. The red eye reflex, which is something you may have experienced or have seen, is not terribly useful. I mean, quote from a paper here, it cannot be used, however, to identify causes of poor vision related to retinal optic. So it's a wonderful thing to do, but not very useful. And I'm going to go, in the interest of time, just really go quickly here. I mean, everything on this slide I've told you, except maybe the details. Doing this in the cloud has made it possible for us as a small company with a small but good team to basically improve scale, speed, and cost by at least 1,000x, depending on how you look at it. We also did some load testing, and I think we could ultimately do 1 billion images a year, which is presently what's being done. And that's not surprising because, you know, once you scale things in the cloud, almost anything is possible. I love the fact that you can sort of capture 90% of human expertise in a deep learning classifier. We are also very lucky. This is not the focus of this talk, but we have a partnership with a provider that actually controls 40% of newborn, not controls, but supports newborn babies' birth in this country. So we have a real shot at making this real and actually going back to the beginning, offering it to almost everybody, at least on a reasonable scale. And we do this for good reasons. We want to protect vision. And so at this point, I've talked mostly about content, philosophy, whether or not health AI is useful here. But Stepan has really done some of the key work on implementing that. And I should say we started like 2.5 months ago based on a prototype we had. So I'm suitably impressed. It's all working now.
Yeah, thanks, Jochen. Yeah, can you hear me well? Sounds good. Yeah, I would like to start by introducing myself. First of all, I'm dad. I have 3 kids. They're lucky not to have any issues with vision impairment. I love this particular picture. I think that my newborn daughter looks the happiest person in the world here. I'm CTO of Productize. So we are one of the top AWS partners with artificial intelligence focus, and we are also a solution provider. Yeah, I would like to start with to warm up you with a short demo, what we have and how it looks like from the user's perspective. Let me switch to demo mode. Yeah, it is here. What I like about the AI solutions, they have a big iceberg under the hood, but as a user interface, remember Alexa, they are very tiny. There are tiny applications that solve a $1 billion problem. So this is kind of pre-labeled images by AI that is being captured and being provided to doctors, and doctors are usually looking at those images as a whole. So it's kind of an art to see what's going on there, and they can dig deeper, see the predictions, and basically augment it with their own annotations. And we experiment with some like bias preventing features that may or may not exist in the system. So you can go through this. Like this one is normal. It's very healthy. The other one is, you see, it's obviously it's 100% abnormal. You see some like blood parts here, and you can just and this type of, and an interesting fact that like 99% of the images could be screened automatically. So we basically eliminate 99% of manual effort. So and make doctors to focus just on a 1% of very complicated use cases and complicated like pathologies. So they can this particular eye is obviously very abnormal in this case. I will continue with PPT. Yeah. So in my part of the presentation, I would like to spend some time on more practical aspects of that project, and I would like you to leave with the clear idea or even action items that can facilitate starting disrupting your enterprise or even disrupting the industry you represent. I would like to cover an aspect of connecting the dots between business, science, and technology. Obviously, every project starts with a business need. There is a technology, but there is something in the middle that is being called a product management, which is and there are no trained AI product managers, and this is something we should really talk about. Then we will spend some time about discussing commoditized and not commoditized AI and machine learning, what to use, what to start with, to help you basically build a quicker prototype and move further to life. We will talk about the infrastructure for transparent and reproducible healthcare AI. This is an interesting aspect that really differentiates a healthcare AI from all other industries. So we basically need like this infrastructure for reproducibility and transparency. It's kind of a need of all AI systems, but in healthcare it's much more relevant. And we will talk about auditability and governance of healthcare AI. So, and yeah, at the end, I would like to spend some time just giving you tips how to leverage AWS. Obviously, you're here in this conference, and this partner X system to accelerate the project. So, on a high level, I believe you're very inspired by this conference. You see a lot of opportunities. You see all the robots. You watch TV. You read the magazines. You're kind of you're talking over beer about preventive healthcare, some virtual assistants, robots, and so on and so on. But then you're back home and you see what technology is available. So this is a screenshot from Amazon recognition landing page. So, the crucial thing is to connect the dots between the business opportunities, the high-level ideas, and the real technology which is available in the marketplace. As I mentioned, we have what usual project, what the general project in enterprise, how general project in enterprise look like. There is business, there is product management, there is project management, there is IT team and engineering team. As I mentioned, there are no trained product managers for driving AI products and AI solutions. And what we really recommend is to run that kind of workshop. You can invite AWS solution architects to this workshop. You can invite AWS partners, and that could really structurize the main goal. Of course, you can collaborate a lot between business science and technology, but the goal here is to structurize this conversation and make it really actionable and has the very precise agenda, a duration, and the final goals to achieve. And having a third-party like expert in a room can basically accelerate the decision-making process and so on. So the usual plan of that type of the workshop that we see and that AWS team recommends is first of all inspiration. Of course, we kind of covered this inspiration part during this conference. Then some education, use case qualifications, and qualification and data cartography. And deliverables are usually like adoption roadmap and solution architecture. As part of the education, I really encourage a technical team and the data science team to educate business on a simple aspects. This is a very basic aspect that business needs to understand in order to talk the same language with the technology. For instance, this is a computer vision 5 years ago. As Jochen mentioned, we were detecting arteria, we were detecting veins, fovea, and all other parts of the retina. Then we're applying some like measuring distances and applying some algorithms to basically detect pathology. And how computer vision works right now, it's much simpler. It's a neural network that automatically extracts features and basically writes the algorithms right from the data set. That's a simple concept. You shouldn't go deeper into details as a business, as a manager, to participate in this workshop and be very productive. And of course, everything starts with the business metrics to improve. And the goal of that type of workshop is to formulate a machine learning problem. and then use the machine learning capabilities to drive the business opportunities. That's really simple. And the crucial and interesting part here is finding the most impactful and less complicated use case in your enterprise. So, applying some a very naive and simple like science here, and plotting the scoring a business impact from 1 to 10, and scoring a technology readiness from 1 to 10, and scoring a complexity of implementation and integration in an enterprise from 1 to 10, you can easily prioritize what to work first on. And I would like to, a couple of examples for you about this, like the issue of filling the edge between available technology and not available technology. For instance, self-driving cars on a public roads is a bleeding edge. So we don't have it, and fully autonomous self-driving cars. However, an autonomous vacuum cleaner is a commodity. So, and the same way, autonomous car in a well-defined environment, when you each centimeter, each foot is being mapped, is also a kind of commodity. So, however, the visual inspection done by the same car on a manufacturing floor is an opportunity. So it's kind of slightly shifting and slightly changing a use case can make your implementation really easier using a commodity AI, and on the other side, it can make it really complex, and it can start a year-long research and R&D process if you will not define that final goal in the right way, and if you will not define that use case in the way it could be implemented. So, talking about our scope and with Prevent, you heard the mission is to scale newborn screening. And as a business KPI, what we define is cost per screening. On another side, it formulates a machine learning problem as a binary image classification. It's a well-known machine learning problem. It's we've been classifying dogs and cats for a while, and for instance, classifying dogs and cats is a commodity machine learning because A, it's a well-known machine learning problem. B, we have a huge data set, a huge labeled data set. However, classifying retina images from normal to abnormal is a huge opportunity. So, as we mentioned, we have a 400K unlabeled images, and our machine learning success metric is 95% of recall. So we don't want to miss pathology, of course. And as a business KPI, it's a 10x reduction of screening cost. So, data cartography is a quite important topic I would like to spend time on. Quality data should become a business strategy and not a problem of data scientists. This is a key message I want to deliver to you. So, as a not bad, but some. It's maybe not the right word here, but bad data scientists usually expect to get clean and structured and labeled data to train the models. However, what we think that good artificial intelligence business person need to do is to design a business that produces new and actionable data on its core. So there are many options to get quality data. You can buy. There are marketplaces. Depending on your domain, there are marketplaces you can buy data. You can use annotation vendor. There are many vendors like even Amazon SageMaker Ground Truth. It uses mechanical Turk under the hood. You basically upload unlabeled data. You configure the jobs, and it's being done either by crowdsourcing or by well-trained labeling teams all over the world. You can annotate it manually by yourself. It's probably the most. It's also expensive, but the most time-consuming approach. You can use public data sets, of course, and the approach that I like personally and I recommend is inventing data-centric business. So it should not be just on the side of your process. It should be incorporated, and your system should be self-healing in terms of producing high-quality data. With Prevent, what we choose, of course, there is no silver bullet. Usually it's a combination of different approaches. We build doctor-in-the-loop workflow. We manually annotate using doctors a small data set, and we use machine learning assisted annotation workflow when machine learning helps us, first of all, prioritize data to be annotated, and then suggest the different, suggest the labels in certain cases. And also it can be used to clean up the data. Of course, there are a lot of bad data, not the images that are corrupted. You can use machine learning not to spend money on doctors. Doctors are expensive. Their time is expensive. Not to spend money on a crowd, but you can automatically filter and clean up the data using machine learning here. Changing the topic, moving next. So explainability. For those for those parents who has tweens, they can usually differentiate, of course, between two kids, but they never explain what exactly how their kids are exactly different. The same way with doctors, they cannot explain. If you ask the doctor why this particular image is abnormal, they cannot explain it to you, because it's kind of art. They see on that image, and their neural network in their brain is so well trained over the last 30 years, so they just they give you an answer right away without even thinking about this. That's an interesting challenge, and without digging into details, there are like attention layers. We can highlight activated neurons, but as a business, you can I would like to leave you with a message that technology is here, and it is available to explain the predictions. So we can even predictions based on images. So. You can incorporate it into your workflow and can advance that workflow by having these explanations. Transparency and auditability. Here is how machine learning were 5 years ago. There was a business problem, there was a data, there was a magical data scientist in a black box, and high hopes and some result at the end. Nowadays, it's especially this year, it's time to productize the machine learning and AI go live, and any production system requires more clear process, more auditable and transparent process from the very beginning to the final prediction. And what's happening at this moment in the industry? So we're basically whitening that black box and explaining different management teams, explaining auditors how actually the process works, from the raw data set to data annotation to experimentation to model cataloging to testing, production inferencing, monitoring, and maintenance. So there are much more steps here. I just highlighted the main ones, and the goal here is to have each of this step really logged, audited, and transparent. For instance, we know each prediction, and we can trace it back to the model that has been used to produce this prediction. We can trace it back to the data set that has been used to train this model, and we can trace it back to the labels and the process and agreements between doctors that we used to train and label this data, to label the data and train the machine learning model. So the system is much more transparent at this moment. This is not going back to the question about commodity, and it's not available as a kind of AWS service yet. It's usually done by some, not custom, but it's done like by engineering teams in collaboration with management teams, and there are technology blocks that are available, and but most of this type of auditable and trusted environment should be built basically from scratch at this moment. I believe it is going to change in the future, but this is the state of this machine learning ecosystem at this moment. So I would like to spend last 1-2 minutes by providing you some tips and recommendations how to use with AWS. First of all, find your account manager. If you haven't spoke with him, just reach him out and talk about your business. This is their job. Of course, their job is to they have a lot of KPIs rather than just selling you a usage. They have a lot of KPIs and incentives to help you and grow your business. They can connect you with some industry experts within Amazon. They can connect you with solution architects. Just feel free to use it. For instance, they can co-fund workshops and proof of concepts. Especially if you are innovating from bottom up, you need some like a small like R&D budget, and you're trying to build a proof of concept and pitch it to the management team. Usually, it's nice to have to solve that chicken and egg problem, and use AWS to co-fund this like workshops and proof of concepts. Then co-market your project. As an example, the Prevent, we're here on a stage. This is also an effort of both Amazon and a partner ecosystem, so you can get exposure. If you're enterprise and if you're a global enterprise, you should always also market your project just to transform your culture and transform your perception from the community. Align your culture with AWS. Just learn how they learn their leadership principles, and this is actually a good chance for you to, especially if you're like well-established and legacy enterprise, it's a good chance for you to transform your own culture and be more AWS and technology-driven, AI-driven company. Use certified partners as an AWS extension. It's not only Productize, but I would say it's not a formal label. It's not a formal badge. They do a really good job on interviewing customers, interviewing engineers, interviewing managers, reviewing the processes, and so on and so on. So it's these like competencies. It's not just badges. It's a real work that has been done with by AWS and partners. So you can make sure to make sure the quality is on a level of AWS. A few takeaways. Technology is here, so it's time to transform your industry. Basically, I wouldn't say it's just this year. It's just this year. A lot of services has been released, and for productionizing the solutions, you really need to follow the best practices from the classical software engineering world, apply methodologies, apply processes. It's not a hackathon type of projects anymore. For design your business to be, in this case, FDA compliant from day one, but if you have other restrictions and regulations, it's also to be considered from the day one. Yeah, and save time to market by leveraging AWS and partners ecosystem. That's it what I want to talk about. Thank you so much. Happy to take questions.